Hello, this is Michael presenting stage 3 of Standard 6. So let's just dive right into it. Part A asks for create two new columns of transformed data by calculating the squares of D series and the reciprocals of the E series entries. Find the least squares regression line connecting these two columns of data. What is the correlation coefficient between the two columns of data? So this can be achieved by doing the graphing part of your calculator here. Rather the statistic analysis part. So here I have entered all the data for D onto my calculator. As you can see, they're the same here, and same for E, which is on this column down here. It's exactly the same, copy and paste from the problem. So now where it gets interesting is we need to create two new columns, which I named DS, which stands for D squared. It just something helped me to remember, and ER, which stands for E reciprocal. It could be anything. It's just whatever helps you to remember. And quick way we learn how to do this with our calculator rather than by hand, which I did down here, is simply plug in what you want the data to be transferred to. So I want the entirety of column D to be transferred into this column, but I want them to be squared. And same thing for this. I want the reciprocal of E, which can be achieved doing this. So now I got my two new columns of data, and it asks to find the least square regression line, which can be found by doing stack calculation, which I already did. So let me just flip over here. Yeah, so this is my stack calculation. I copy down the variables, which you can see down here, and the correlation, which is R, you can see is 0.999996, which indicates a very strong linear relationship because it's very close to 1, as we have learned in class. And just to have another visual of how strong the linear equation is, here I've plotted the data where how it's gonna look in the graph. So for the X I have DS, and for the Y I have ER, and I will let you see, and this is leading into B as well, I will let you see why simply D and E wouldn't work. So if you have D over here and E over here, you will see it's going to create an exponential function instead of a linear. So B asks for use the linear relationship between these variables to write down a simple equation that describes the relationship between D and E. So as we can see here, this is exponential, which we can't use. So in order to have a linear equation, we have found in part A, if we do the square of D and the reciprocal of E, it's going to produce a very linear equation. Yeah, let me just switch it back here. So I'm going to want DS down here and ER for my Y. There we go, and that's it. And so now the equation, we still have to have it in where it fits the data, the original sets of data. So now we have right here, which is 1 over E is equal to 1 over E means the reciprocal of E, 0.000, yeah, I made a mistake here by not adding the 0.000682 times D squared plus 0.002028. And here and then the equation can be simplified to this just by doing a little math. So for part C, we're asked to predict the E value that should correspond with the D measurement of 36. So the given information is 36, and we know there's an equation that we can use to find this, to find the missing E value, which is the equation that we figured out in part B. and that is E is equal to 1 over 0.000682 times D squared plus 0.002028. And if we just plug in the D value here by replacing D with 36, we should be able to calculate E, which ends up to be 1.1288. Thank you.